I hope you had some awesome conversations at lunch. I know I did. One thing I forgot to mention was that Friend and Centered sent us their brand new edition of a Monopoly game that is intended to engage communities in transportation justice. And so we have the game on hand. I don't know if you saw it during lunch, but it's going to be here tomorrow as well. And if you want to play around, let us know. We'll have a round tomorrow at lunch, as well as open office hours with Amy to troubleshoot, ask questions, see anything in more depth than you were able to see today. Without further ado, I'd like to introduce our next speakers. We have a very exciting session. Thomas Craig, Anson Stewart remotely, and Kurt Winner are going to present joint work that they've recently done to take the sidewalk data and be able to, at scale, join it to road data and doing it in an open source kind of way, which is the way. So we really appreciate you being here. Thank you so much.
Thanks, Anat. Really excited to be here and present our exciting work. The title of our presentation is Bringing Sidewalk Data into a Washington Statewide Access to Destinations Analysis. I am Kurt Winner. I'm joined by Thomas Craig, and Anson's with us remotely. He'll jump in some later slides. Just a quick agenda for what we'll be stepping through is an introduction and background on this project, touch lightly on the statewide sidewalk data, and then we'll walk through open source sidewalk data processing tools that we're utilizing to build an analysis. We'll touch on our partnership with Conveyal, so WSDOT and Conveyal's partnership. Then I'll be doing a live demo of Osmix, which is a merge tool that can bring the sidewalk data together with OpenStreetMaps networks as well. Touch lightly on some results from our analysis, and then we'll kick it over to Anson for some discussion on open source tooling and Conveyal's work with improving processes with other agencies. Now I'll pass it over to Thomas.
Awesome. So yeah, I'll first just kind of talk a little bit here about what an access to destinations analysis is. This is a process that we're pursuing within the Public Transportation Division at WSDOT in collaboration with other divisions at the agency and also partners in a technical advisory group from around the state. Basically, an access to destinations analysis is a quantitative analysis method that measures an amount of access available to some group through a transportation network. Access being defined here as the ability for a traveler to reach some destination from some origin within certain travel parameters. And basically, this is a performance measurement process for a transportation network. Access is the point of transportation. We want to get places. And so thinking about how much access is provided by a network is a way of thinking about whether that network is doing its job well, whether it's providing good access, how much access, what types of amenities it's providing access to, and for whom. We won't go into all the depth about the model that we're developing along with our technical advisory group, but thanks to the OS Connect data source, we're able to think about different walking profiles so that we can measure access differently for different types of normative users. We have walking profiles that represent a person with no disabilities in a normalized sense, a elderly user or someone who uses a cane, again in a normative sense, a power wheelchair user, and also a person living in a rural community who may choose to walk on roads without sidewalks because there just are very few present. we're also working with that technical advisory group to think about the different destinations that we're measuring access to. So using different open source and authoritative data sets, thinking about different destination types like food access, jobs access, healthcare access, and more. So that's kind of at a high level what an access to destinations analysis is, and we're doing that on a statewide basis. Why are we doing that? We're doing that because it's the right thing to do, but also for two particular reasons grounded in our responsibilities under Washington state law. We're planning to incorporate this into the statewide public transportation plan that the Public Transportation Division puts together about every 10 years, and that we're expecting to publish next in the first quarter of 2027. And state law requires that that public transportation plan articulate the state vision of an interest in public transportation and provide quantifiable objectives, including benefits indicators. That bolded part within this slide, provides quantifiable objectives, including benefits indicators, is maybe something that we haven't really done super effectively before. And we hope that this destination to access analysis will provide a really somewhat objective, although community-centered way of thinking about what is the benefit of public transportation. How do we quantify that? During this current biennium, we were also assigned by the legislature the responsibility of following up on the frequent transit service study from 2023 and assigned funding in order to, in particular, look at a demographic analysis and incorporating demand responsive transportation into our previous frequent transit service study analysis. So we're both going to be layering demographic data from the American Community Survey on top of that destination access analysis, as well as incorporating GTFS Flex data in order to measure access to destinations through demand responsive transportation in order to meet the requirements of that proviso. So that's some of the context for this analysis, and with that, I'm going to go ahead and hand it back over to Kurt.
All right, so I'll just quickly kind of share, endpoint of this analysis to give you some context for what some of the results look like. And so we're utilizing Conveyal, which is a accessibility analysis tool that's available on a browser. It utilizes an open source R5 routing engine. So the routing, a lot of the back end information is available open source. But they also create a front end application that allows you to enter custom navigation networks. So we can include sidewalk data, OpenStreetMaps data, GTFS data to create a travel network. And then you are also able to configure different parts of the trip in order to run comparative analyses. So the image I have on the right side of this slide has a blue origin marker. It's a single origin trip analysis. The blue/purple isochrone represents a 35-minute walk shed at a brisk pace, and that's kind of using any path, including a roadway, sidewalks, anything. Whereas the red isochrone represents a same 35-minute travel time frame where only sidewalks are present. So this traveler is limited to only the sidewalk network, and they are moving at a slightly slower pace. The black dots in this instance represent jobs. They're pretty clustered at this zoom level. Within each isochrone, there's a number of jobs that are accessible. So essentially, within the blue and the red, on the right-hand side, you have a count of how many dots or jobs in this instance are reachable given those travel parameters. Within Conveyal, you can also see a pretty straightforward graph that tracks how many jobs are accessible over time. Those are kind of the sinusoidal curves in the upper left-hand side of the image, and it's comparing the blue path with the red path. It's kind of the same distribution of those two different walking profiles. It's highly configurable. You can see a preview of some of the configurations down on the bottom left-hand side of the image. Essentially walking pace, the type of access and egress mode. You can toggle between walking or biking. You can change the types of transit modes that are available to utilize and which schedules are included in the model as well. So that's a preview of kind of the end result, what we're working towards. So when we're able to bring in sidewalk data, we can kind of do that comparison between where sidewalks are present and where someone may have to, where only roads are present, and it's a more fragmented travel situation with the sidewalks. So accessing statewide sidewalk data, just to highlight a couple tools that have already been mentioned. There's the TDEI data repository, which essentially has access to those jurisdictional data sets. You saw Jeff earlier kind of search in OS Connect for those different jurisdictions. That same functionality is available in TDEI, and you're able to download and export files in OSW or OSM formats. I also utilize the OS Connect data viewer to just get an overview of the data set and what's available. You can hover and click on different elements of the data to see what's, which jurisdiction it belongs to, see specific attributes about those segments, et cetera. So it's very helpful for context setting and some other additional information. Some other open source data processing tools that we're utilizing in this analysis are kind of broken up into a couple points here. So to build that routable network within Conveyal, we're utilizing the OS Connect data set, so the sidewalk data for the statewide. And then we're also able to pull walking paths, roadway data, and other paths that aren't captured in the sidewalk data set, utilizing from OpenStreetMaps, utilizing Overpass Turbo API. We're also doing some file conversions to get these files in workable conditions within Conveyal. Conveyal requires a PBF file type, so you can do that file conversion and a couple cropping and other file processing functionalities using a tool called OSM Convert. This is really useful for Windows users. It's one of the only direct to Windows options that I was able to find available. There are other tools like Osmosis and some other things that can create the same functionality. And then I'll get a little bit more into and do a live demo of Osmix, but it's helpful for PBF review. PBFs are not really human readable and are challenging to look at, as just a user without doing some additional work. So you can do that within Osmix, and you can also complete the sidewalk and OSM data merger. To build the travel networks, you also utilize GTFS feeds that we can pull from transit land. And then we're looking at other destinations. So I talked about jobs. Jobs are useful. They're, can represent an economic opportunity beyond just the job itself. Jobs can be at stores or restaurants or other destinations that other travelers are getting into. And it can also represent, land use as well. But there are some other critical destinations that we want to measure access to, and we're utilizing different data sets to do that. For jobs, we're using the loads data, which is available to directly load in that Conveyal front end. But we're also pulling data from the official Washington statewide data sets. The open data portal has, mapped hospitals and other key destinations that we may not want to leave to an open source data set. But for some, less important or lower priority destinations like restaurants, entertainment centers, etc., we can utilize some unofficial open sources like Overture maps, and Foursquare, and OpenStreetMaps as well. And then all of that is being used to upload into Conveyal, which again utilizes that R5 open source routing engine. And with that, I'll pass it back to Thomas to talk about the partnership with Conveyal.
Yeah, so WSDOT has now been working with Conveyal as our destination access analysis tool for about 3 years was when we really kind of started initial testing. One of the things that really made this particular, or I guess two things I'll hint at that really made this tool attractive to us in particular, was that it's built on that open source R5 routing engine that Kurt has mentioned a couple of times. Ultimately, it's very important to us in this process that the results that we calculate are replicable by anyone who wants to go through the process, that we can publish documentation that allow our exact analysis to be rebuilt, that every part of it is transparent. And so it was pretty critical that the routing engine that we use was something that is accessible by anyone. At the same time, we didn't really have the technical capacity in-house to train ourselves up to be able to interact with R5 through a wrapper like R5R that is available to someone more technically savvy than myself. Kurt could do it I'm sure if I gave him plenty of time. But we don't necessarily have that time, and we do need to kind of move quickly. And Conveyal provides a user interface where we're able to configure very precisely what that routing engine is doing. And so it was very useful for us in that context to be able to get up to speed, start showing results quickly in a way that we knew could be replicated in a fully open source way in the future. Also the scale and speed at that scale. This is technically a type of analysis that could have been performed to a degree within components of the proprietary Esri stack that is very commonly used at public agencies. But we don't want to take hours to set up a process and then leave our computers on overnight in order to get any results. And it's very nice to be able to load information up into this routing engine and be able to calculate results for half of the state in minutes, not hours. So that was the tool that we chose through our review of the industry and went through a procurement process in order to get access to that so that we could use a tool that really fit our long-term needs. Conveyal has taken some requests over time in order to think about particular tools. You're going to hear about the results of that. We applied for a SCLEO grant from the University of Washington in order to get funding to build this Osmix tool in order to be able to work with the statewide sidewalk and roadway networks in tandem, because we need to be able to measure access across both of those. And Kurt and Anson will go into details about that. We'll also be working soon in order to add in features to the R5 routing engine and the Conveyal interface in order to process the GTFS Flex data that I mentioned earlier in order to be able to calculate access results for demand responsive transportation as well. So this work is being produced as open source code. Osmix, you'll see, is available for download and use, and also for use directly in a hosted version. So these are tools that you can use yourselves at no cost, and we're happy to have been able to not just build processes that work for WSDOT, but also processes and tools that can help other communities and agencies around the state and around the world. And now I'll hand it over to Kurt to talk more about Osmix.
Okay, I'll do a quick introduction on Osmix and then hopefully switch to a live demo to show how it works. It's a client-side in-browser OSM merge workflow. So for our purposes, you can upload a PBF of the sidewalk, the OS Connect dataset, and custom downloaded OpenStreetMaps dataset. Bring them in together and merge them. That process and all computation happens locally rather than on a server. You'll see for the data set I'm utilizing, which is based in Yakima, Washington, it works extremely quickly and is something that brings a couple processes that may have taken a couple different tools and a couple agonizing, and you may have had a hard time merging two networks utilizing one cohesive process under one very lightweight and very accessible process. So you can essentially, I'll transition to the browser now. Okay, so the interface of the browser is pretty straightforward. So the view in the browser, now that you can see it, is relatively straightforward. There's a check system button up top, which will analyze essentially your local system to give you some max array sizes that you're able to run, gives you how much usage is being done. A lot of these analyses, unless you're doing something at the scale of a country or have a 4 gigabyte RAM, you should be in good shape and able to run the analysis or this merge. There's an example file, but I have prepared a couple local examples from Yakima. You can see here a couple different file types have been added. We initially were just looking for the PBF because we're working with Conveyal, and that's the output kind of upload file that we're looking for. And so you start with a base OSM file type. I have a cropped version of our Southeast Washington overpass file. It loads in and kind of shows you the extent of the network. It gives you the merge steps here in the upper left-hand side, and I'll walk through those kind of one by one. But you can also, so this was a PBF file, again, not very human readable, and you can kind of go in and select specific elements within the PBF and see what kind of tags are present, what information is present within the file you've uploaded. You can do some light navigation, but it's a good way to kind of get an overview and see what's going on in a PBF relatively quickly. Then you can open the patch OSM file. So in this instance, we'll be using the Yakima City TDEI export. So that's the OS Connect dataset for Yakima, Washington. Open that. It very quickly uploads into the file. You can now see some of these ways have been duplicated, and you can click and see that this is now a sidewalk dataset with the schema and attributes that we'd expect from the OS Connect data. So width, it has the surface type, it has the incline, and some other information. So helpful to navigate and kind of just review data sets as you're entering them. It moves relatively quickly, particularly with these smaller data sets, but even things, we're working usually at the half statewide scale. So, if I'm merging all of Western Washington, that usually takes under a minute to do. I'll step through and verify each step. Essentially, we'll deduplicate nodes and ways in the base OSM file, deduplicate nodes and ways in the patch OSM, merge those two files, and then do another deduplication after the merge has occurred. And then it creates new intersections based on where pathways have crossed, and it makes sense elevation-wise for those pathways to have an intersection that would allow someone to route along a new pathway from the merged file. Okay, so first it gives you kind of step-by-step information. Deduplicating gives you all of the information, so like which nodes it's deleting. You can look at specific information about those nodes. It gives you how many, and you're able to download the change data sets either in JSON or OSC file types. After I apply those changes, it just asks me for the same verification essentially from the patch OSM file. Same process where it shows the nodes that will be changed, gives you a count and changes that will be applied, allows an export of that change set as well. Now we've deduplicated, and we can generate the direct, we can direct merge, and so generate the direct changes. This again shows how many changes, how many of the ways and nodes will be merged, gives you the same change data set available to download here as well. And then after we've merged, it now allows deduplication of the merged file and gives you the same data set there. Last step is to create the intersections. Note that we strategically identified like bridges and tunnels and ways that wouldn't intersect, and Conveyal was able to work in a workflow that does not include intersections for places where like elevation-wise it would not make sense. Again, gives you one last change data set that you can export and review. And then voila, you have a merged OSM PBF file that you can download, and you can take this and directly upload it into Conveyal as a new network that you can run analyses on. Okay, so essentially now you can upload this newly created network into Conveyal to utilize as your routable network in the model. You just upload that new PBF, so the PBF that we downloaded from the results of Osmix. You can add GTFS data files. You can reselect previously utilized GTFS files, or put in whatever customized GTFS files you would like. You can also apply custom configurations. So you can say that I only want this network to allow navigation on sidewalks. You can say that this profile should only navigate places where there are curb cuts existing, so limit any navigation across places where there's a raised curb and or steps that would be challenging for some pedestrians. And there's also functionality to take advantage of the OS Connect incline data, so you can set limits on how high or low of a slope is navigable given the data set available. Here's an example of some results from a spatial analysis that is comparing two of our walking profiles, the profiles that Thomas highlighted previously. One is able to navigate along any roadway or pathway. That is represented by the red intensity of the jobs. Jobs accessible is what's being shown here. And then that's being compared against a walking profile of someone that may utilize a cane, is only comfortable navigating on sidewalks, moves at a slightly slower walking pace, and is only able to navigate slopes under 8.3%. So you can see with the intensity of red the kind of difference between the number of jobs that are reachable from each of those origin points. There's essentially just highlighting the network where high transit availability and sidewalks can maybe bring that delta closer together. But for the most part, most of Spokane, Washington here shows that many more jobs are accessible to that first walking profile than the second for most of the city. And with that, I will pass it over to Anson, a truly hybrid presentation here.
So yeah, thanks a lot, Thomas and Kurt, for that walkthrough, and we are really grateful for the partnership and the collaboration you've described. This is kind of our launch announcement for this new Osmix tool that we've built and that Kurt just walked us through. If you're interested in more of the technical details of it, my colleague Trevor, who led the development of it, has just published a post on our blog. So anyone who's interested, please do see blog.conveyal.com for that. That has a summary of the development and the features. Just again, this merge feature that Kurt walked us through. But even if you're not merging different data sets, this may be useful for format conversion between various geospatial formats. And the library also, this new Osmix library has tooling to generate mapbox vector tiles and even kind of just draw images of OpenStreetMap data. So this is very much in line with our commitment to transparency and reproducibility. This Osmix library, which has a number of these utilities, is available on GitHub, permissively licensed, so folks can feel free to use it, reuse it, adapt it. And then, we have the hosted version as well, which it's hosted in that it's just an easy website to go to into your browser. You don't need to install anything, but it's actually not running any computation on a server. It's all running locally in your browser. We have a number of other libraries that we develop and make available open source. R5 is the one that Thomas already mentioned. I know R5R is fairly widely used. That's kind of an independent third-party wrapper library around the core R5 routing engine we develop. I know folks at King County Metro have used that in the past. So a range of other tools available there. I will also say that the R5 and our analysis platform built on top of it are starting to incorporate some of the GADIS specification in terms of incline values and some of the other sidewalk attributes that we could use to set custom routing profiles like Kurt and Thomas were mentioning. And just thinking about ways to scale this up, we've been really excited to see Washington State at the cutting edge here, and we're hoping to kind of drive adoption around the country. We're doing that in part through a range of other state DOTs, city DOTs, transit agencies that use our analysis platform. There are just a few examples of that. Caltrans in their new CSIS setup has 9 quantitative metrics. 3 of those are destination access measures, kind of similar to the access to jobs measures Kurt was showing. And so we're excited that as better data on sidewalks become available, this type of analysis that's already being done statewide would become kind of much higher quality. Similar interests in Minnesota, where the Conveyal platform is used to evaluate a number of kind of active transportation programs. And then for folks who may be interested in this kind of concept of destination access, I also put a link in here to a cool analysis done in Massachusetts by the Boston Region MPO, CTPS, that has a cool look at kind of costs and time of travel for different users. So these are, I think, really exciting opportunities to expand the use of detailed sidewalk networks, and a number of the people I've talked to have been very interested in kind of following the work that's been done here. And I'll just mention one other channel for kind of dissemination and adoption that we're excited about. And this is thanks especially to Kelly Rogers at Oregon DOT and Deanna Belden now at Texas A&M TTI. They've helped convene a destination access community of practice So Kurt and Thomas and I have all kind of been participating in that and been able to exchange ideas through that. And so if there are folks in the room who are interested in this kind of access to destinations analysis and some of the related land use and network data improvements that are coming down the pipe, please feel free to get in touch. We'd welcome, I think, more people participating in that community of practice as well. So yeah, at this point, I think we're open for questions and discussions. Thanks again for your attention.
Thank you all. We're happy to take any questions you have for any of the three of us.
Is these reports available somewhere we can go look at them right now?
Sorry, could you clarify which reports?
Just like your map of access to jobs. Yeah. Just the maps that you generated with access to jobs. Like, is that published as a report or a website like right now?
Not yet, but soon. So we have been working on this statewide destination access analysis project for, in some form, years, but really very intently over the last year. We have that technical advisory group that I mentioned earlier that is helping us design our methodology. And the first report publication will be coming up in June. So we have a technical advisory group meeting next week to talk about the demographic analysis portion of that report. One more in April to talk about demand responsive transportation. That will finish off a series of 5 advisory group meetings we've had since August of last year. And we'll really kind of finalize our methodology that then will be published in a report in June. That'll include a lot of documentation, maps, really quite a lot of maps. And then will be worked into the public transportation plan to be published in Q1 of next year. So what you saw today was sort of different types of test analyses and things that if you're interested in analyses of your own jurisdiction, things that we could help you through and potentially create some reports tailored to your interests in the short term, capacity dependent. But the official publication will first happen in June.
Hi, this is Anat from the Tasker Center. Thank you so much for this presentation. This question is actually more maybe towards Anson, but I'm not sure. So obviously these are the types of analyses that we're super interested in. We also work with highly heterogeneous groups of people who are trying to traverse the network. How does R5 manage dynamic costing of the edges? And just for other folks in the room, what that means is, can we really accommodate the kind of routing that's very specific to the person I'm modeling needs curb ramps, but can go up really steep hills, but doesn't want to go down, lower incline hills. Does R5, the open source routing that is being used here, does it accommodate for that? Or do you have to pre-bake the scoring? And the other part of the question is, if you do have preset types of pedestrians that are being modeled as opposed to letting it be flexible, what is your way of assessing that there's true fidelity between what you're modeling and how people actually move on the ground? Sorry for the multi-part question.
Yeah, it's a great set of questions. So at the moment, there are kind of 2 approaches we take. One is setting kind of custom traversal permissions on certain links. So they're basically modules you can set up to say, okay, we will bake into this version of the network, allowing traversal of corners without curb cuts, but not slopes above a certain amount or whatever. So that is fairly flexible in that you can kind of pick and choose different restrictions. But once you bake it into the network, it is then baked into the network. That said, the process of rebuilding a network in the Conveyal tool is fairly quick and straightforward. So it's not as flexible as it could be, but still not too onerous to kind of iterate through. The second kind of approach we can take is more of kind of a generalized cost or impedance based traversal. So in that we can set kind of penalty functions on slopes or traversing edges that have different, say, tree canopy values or something. So that's a lot more flexible. In terms of that, then how to close the loop and kind of test the fidelity of, the travel times or traversal impedances that we're calculating with the kind of lived experience, that's, I think, still more of an open question and part of what we're hoping to learn more through events like this.
Hi, I had a question. We've talked a lot about sidewalks and traveling along the road network, but I'm wondering how you've incorporated crossings into your analyses. I'm thinking about, a lot of the crossings are unmarked crossings, and maybe for the different user profiles that you've talked about and the 4 different user profiles, maybe there's a mom with a child who's not willing to cross in an unmarked crossing, and how is that incorporated into the analysis that you've been working on?
Yeah, so I think that most applies to kind of our conversation with the technical advisory group about the walking profiles and what to and what maybe not to include in the considerations we're taking into account with those. There's a big interest in taking sidewalk condition into account, a lot of interest in crossings and different safety measures that I think, crossings are maybe the easier one to take into account with this data set, but based on our conversations with the technical advisory group, that wasn't necessarily a big priority compared to some of the other things we're considering. I will say that we're considering this very much a baseline analysis where we're hoping to iterate and continue measuring and comparing different components. So I think bringing in crossings, marked crossings, and different kinds of pedestrian levels of traffic stress are something we're very much engaged with and planning to probably implement after maybe the initial report in June.
I'll maybe add just a bit of context kind of about the statewide analysis as well and our decision making there, which as we mentioned is kind of really in collaboration with that technical advisory group, which has been a group where we're trying to both receive feedback from technical advisors while also training those technical advisors to understand the details of kind of what comes into an analysis and think about balancing how it is that we develop meaningful analyses that analyze parts of human experiences, but also are easy to communicate and understand. And I think it's been, that we did discuss crossings and also not just the difference between marked and unmarked crossings, but also, for example, crossing a 4-lane highway versus a 2-lane roadway, and thinking about actually kind of specific to your example, the context of a parent with child kind of came up. And it's been a process to balance that, complexity and sensitivity to different lived experiences with ease of communicating the exact parameters that we're using, as well as just the amount of data that we have to publish. Right now we're working with 5 different egress and ingress profiles, walking profiles, plus driving access, so 6 really, and then 6 different destination categories. Now we're doing 36 different statewide maps and tables of data that then each need to be aggregated at county levels, at different levels of aggregation. So we're already talking about an amount of data that is frankly too much for a reader to comprehend in one read through of a report. So then, yeah, thinking about issues like dynamic costing or crossing values start to then add different layers of complexity. And that's been something we struggled with and tried to come to terms with our technical advisory group of, at this first stage, knowing that we'll continue to iterate and improve these methodologies in the future, how in-depth and how complex do we want to get now? That's been really what we've been working through.
Up next is a question from Zoom, if that's okay, and after you. Clifford, do you want to unmute?
Hi, thank you for taking my question. Have you considered traffic calming features in any of these scenarios? Because those are big things that make people feel safe walking, especially for kids.
We're not incorporating traffic calming features now. We are looking forward to hopefully soon WSDOT's publication of a level of traffic stress methodology that could help us kind of really incorporate different features such as those. And definitely something we're looking at in the future.
Really cool work. Thank you for sharing. I want to, I don't know how to say this exactly, but so the keynote speaker today sort of asked us to fast forward 7 years, and he said everything is going to change, and this idea that navigation through the world and access to things is going to be opened up through the use of robots that have this agentic capacity, that are reading the world as it is in the physical world, but in that world, the availability of really good quality data is almost the same as if there is a road there or a sidewalk there or not. So we have departments of transportation. We've got this compact that we've made with our community that we're going to build access for us, for people to get to places. And it seems like we're sort of tiptoeing to this world where part of that access is gonna have to depend on there being the digital infrastructure there also. So in that world, Thomas, whose job is it to build I'm going to use a word that I maybe is not the right term, but the digital twin of the real world, and we are using it now as planners, and like you're referencing this as reports, and we're talking about this in terms of key performance indicators. But in the world that Amos is describing, it's almost as if there is this entire new infrastructure that needs to build the machine readable digital world for us to be able to provide the freedom that everybody deserves to get to the places that they need. And whose job is it to make sure that, yes, there's a curb ramp that's built, but yes, there's a curb ramp that's in the data, and it's readable in an equitable way by everybody's sidekick robot.
Paulo, you're lucky I like taking stabs at questions that are above my pay grade. I mean, that's a question we're going to need to work out together over years, decades, because, looking out, I mean, it's, goodness, I just turned 40 last year. There was barely Ataris when I was born. Now, it seemed amazing that there was mobile phones back in 2007, 2008, smartphones. And now, we're moving on to entire new things. So, I mean, the types of data sets that we're talking about over, the next, 60 years that, God willing, I'll be able to walk around and not be constantly monitored by different types of, hopefully benevolent machines, people behind them. It's going to keep getting more and more complex. And it's going to keep changing. So there's a role for all levels of government, for nonprofit watchdogs and different types of entities to continue to push forward that dialogue. We need to, I really agree with Amos and think, he brought up some really important, points this morning about thinking forward, and that's true. And we also need to think about what we can do today, and what we know we need to take responsibility for today. So this is a non-answer to your question. I think that your question is unanswerable. I mean that in all friendliness, of course. But yeah, I mean, cities, counties, legislatures, private companies that think about their responsibility to a good world, nonprofits, private disorganized and organized residents and participants in this ecosystem. We all need to keep having that conversation. And I guess more than anything, just remember that we are acting in ways that can make the world a better place or make it a worse place, and take that responsibility really seriously.
All right, this is almost the perfect segue to our next conversation, which is about how we coordinate these data conversations and how well are we doing it via people problems and data problems. So I'll call up, well, first let's thank our speakers, sorry.